Good day and welcome to this LTSPice tutorial, part 1, where I'll be showing you how to implement a transient simulation on an RC or RL first order circuit using LTSPice. If you don't have the software package yet, you can easily download it from the internet. Just make sure you have the correct OS selected and boom, Bob's your uncle. After you've downloaded and installed the software, you'll be greeted by the following screen. What we want to do is we want to start a new schematic, as that is where we'll be laying out a schematic and simulating the circuit response. So up the right hand side you'll see all of the functions that you'll mostly use, like placing components or moving components or adding nodes or node wires. And you'll also be using the run function, which is the little guy running, quite often. Then what we want to start is we want to start by adding a component, which is a nice and handy shortcut as well with F2 on your keyboard. We want to add a voltage source. Also we want to maybe add a ground node, as that is the two things that most circuits need to function. If you quick way to add a wire between two nodes is by pressing F3. To place a resistor, this can easily be done by using the another handy shortcut R on your keyboard. Components can also be swapped or merged by using Control E, or rotated by using Control R. Easy as pie. To place a capacitor, you can just press C on your keyboard, and that's it for now. Now we can just wire the whole shebang up, and we're almost ready to run this simulation. Just make sure all your connections are where they should be. As you'll see, when we want to edit a value or change a component functionality, we can right click on a component. For the voltage source, we right click on the voltage source and went to advanced to get the following pop-up. As you see, we want to change the voltage source to a 50 Hertz pulse or square wave signal with a 0 to 5 volts range. And yeah, also we want to minimize, because it's an ideal response, we want to minimize the rise and fall, so that's why I chose it to be 1 picosecond. Don't be too worried about this at this point in time. We just want to simulate the voltage source turning on and off at 50 Hertz. And then we'll be doing the exact same for the resistor and the capacitor. We just select the value denominator labels and we just change them to arbitrary values. And then we can run. When we haven't set the simulation command, this following pop-up or dialog will be displayed. It just asks us for the stop time and also when to start saving data. When we want to probe, we can just click on any node and you'll see the probe icon or cursor pop up. As you can see, for a single second, that's quite a lot of information because we have 50 pulses, which is not required. If we change it to 10 milliseconds, you'll see we only have a single pulse. When we look at 100 milliseconds worth of simulation data, you'll see we have 5 full pulses. When we want to add a cursor, we just click on the trace name at the top of the pop-up window, which popped up when we ran the simulation. So as you'll see, there's a small dialog box that shows you the exact info as to where your cursors are. So if you want to measure time constants or what the case may be, you can use the cursors. If you want to remove something from your plot, it's the same as when you want to remove something from the circuit. It's just F5, Um, yeah, if we want to implement differential voltage probing, we can just drag the probe as you see me doing now. It's quite intuitive. You'll see the red probe, and then as soon as there's another node, the probe becomes black. So um, differential probing is quite intuitive. In LTSPice, you can also display the grid on your plot if need be. Everything that has been discussed up thus far is exactly the same for the RL. So if you want to implement RL, you can just use the delete tool to delete the capacitor, and then we can add an inductor to the circuit and also change its value. As easy as that.